What is the history behind modern op-amps' small size? Imagine shrinking a giant machine into a tiny device that can fit in your pocket. That's what has happened with operational amplifiers over the years. Let's explore how they got so small. Back in the 1930s and 1940s, op-amps were huge. They used vacuum tubes, which are glass cylinders filled with gases that control electrical flow. These vacuum tube op-amps had many tubes, resistors, and capacitors, making them bulky and power-hungry. The first commercial general-purpose op-amp, called the K2W, came out in 1952. It used twin triode vacuum tubes and was quite large, often taking up a whole rack in a lab. These early versions needed lots of space and consumed a lot of power, which limited their use. Things started changing in the 1960s when transistors replaced vacuum tubes. Transistors are much smaller and use less power. Engineers began building discrete transistor-based op-amps, which were smaller than vacuum tube versions. They still used separate transistors and resistors, so they weren't tiny yet, but they were a step forward. The biggest leap toward small size came with the invention of monolithic integrated circuits in 1964. These circuits are made by fabricating all the transistors and resistors on a single silicon chip. The first of these was the A702, which packed everything onto one tiny chip. This made the op-amp much smaller, more reliable, and cheaper to produce. It also improved performance because all the components were thermally matched, reducing errors. After the A702, newer models like the A709 and the LM101 came out. These chips had better performance and cost less, making them popular in many electronic devices. The ability to put many components on one small chip allowed engineers to create complex analog circuits in a tiny package. This is why modern op-amps are so small today. From an engineering point of view, small op-amps are essential for modern electronics. They allow circuits to be compact, reduce parasitic effects, and save power. That makes them perfect for portable devices, sensors, and high-speed signal processing. So, in short, modern op-amps became small because of the move from large vacuum tubes to tiny transistors, and finally to integrated circuits on silicon chips. This evolution made it possible to fit powerful, reliable, and affordable amplifiers into small packages. That's what makes them a key part of today's electronics and embedded systems.